Okay, am I streaming? Am I live? Am I live? How do I know if I'm live, bro? Couldn't see that. 15 view. That's good. Uh, in YouTube Studio. Yeah. Let me go live ini. Okay. Go done yeah. Later. Back. Later. Says I'm already live. So can someone hear me? Harusnya ada suara yang nggak sih? Ada. Oh, can I just do this? Okay, I'm live now. Hear me? Harusnya ada suara yang nggak sih? Ada. Okay, ada suara ya guys. Okay, let's work on this arcade based Cam June 2026. I've done some, which is the network load balancers and application load balancers, and now I wanna work on the internal application load balancer. Supposedly it should be easy. Okay, let's go. Should be easy. Just start it and then open it on a window. Understand. Honestly, this tool is very not very good. It's very distracting. So I'll just hit it. Where is it? Visibility hidden. These two. So I don't need that, bro. I don't need to see the panel. There you go. Just close it. And yeah. Now I have full views. Okay, agree and continue. Biasanya kita just close everything and then open the Google Shell. Continue, maximize it. Because I think working on the Google CLI is better than just navigating through this, because all the comments they give you, all of it are terminal comments. So yeah, you need to be familiarize yourself. First thing first, I'm gonna fix that compute the region and the zone. Europe. Then the zone should be Europe 1C, 1B. Okay, virtual environment keeps the project software tidy and make sure, so I just need to copy all these. Oops. Let's try that too. Yeah, let's just copy everything here because it's basic Python. Yeah, it's activated now. Enable Gemini code assist in. What the hell? What do I need this for? Whatever. Okay, when working on labs like this, on something that you don't know, try as much as you can to write the comments rather than just copying and pasting it, because yeah, maybe in the future there will be a question for this, a task for this, and if you don't know anything about the comments and everything, you're fucked. Okay, I've just okay, click open editor. I think yeah, just write down one instruction. Oh my god, smart banget everything. Click code, no project. Yeah, this right. Authorize the plugin if necessary. If a project is not available, select a Google, select a Google project, Google Cloud project, and choose Quick Labs. Okay, choose this one. Okay, I choose that one, but still say here this. What the hell, what the hell? Maybe it takes time. Switch project. Okay, maybe I'm already using that one. Let's just continue. Yep. We need to create a. Let's open the terminal again. I gotta create the backend.sh file for the script, I think. Okay, so in here we gotta use the editor. We're gonna use this. Now add the following script into the editor. Maybe it's just script to, let's see what it does. Let's close this first. Sudo chmod. Yeah, enable import function to determine a prime, a basic get endpoint, explain, and serve it on 80, and then yeah, run it. Click file save, which is with the Gemini code assist enabled. Oh, we got a prompt. They want you to prompt. Holy shit. Yeah, just copy this and then paste it in here. That the Gemini thing. Yeah, basically the prompt is provide a detailed breakdown of the script and explain the function of each command, which I already did before. So let's see how they let's see how they you know let's see how they explain it. I'll just accept it. The script initializes a Python-based microservice that checks if a number is prime, which is the def, right? Set permissions. Here document, yeah. Okay. Handle incoming GET request. Initialize the server on port 80. No hub. Okay. Okay, we got that. We gotta open the terminal again because we gotta create the instance template. Let's create that. The cloud compute instance template with an S. Create prime calc. Prime calc. Metadata from file startup script equal backend. No address. Tax backend. Machine type. E2 medium. We'll be using E2 medium. This is the blueprint for the backend VMs. Notice it has no address, meaning these backends won't have public internet access for security reasons. Okay, that makes sense. Open the firewall. The firewall should be get cloud compute firewall rules. Create yes, HTTP network default allow source Oops, ranges the IP. Target tags backend. Okay. Okay, we just created a firewall. Let's check the progress. I think it should be done. Yep. Next, we gotta create the instance group. Okay. Cloud, compute, instance group, instance groups. Just use tab whenever you wanna like auto complete it. Manage, create backend. Size 3, basic one. Whoa, I'm so bad at typing. Template, Permcalc, Zone Europe, West 1B. Okay. Oh, there's typo. Okay. After it's complete, go to compute engine VM instances to see. Okay, I will open this one after this finish running. Okay, it takes a long time. Basically, what the command does is to create identical backend compute engines or instances. So later we could add them to the backend that we already created. Okay, you can see the VM instances. There should be 3 instances. Righty. They don't have any external IP because we use no address here. Where is it? Here, no address. Permcalc. And it uses here, Permcalc. Because this is an internal application load balancer, that means everything about the load balancing is configured internally, so it's inside of VPC, so user cannot access anything. So it just can access the external public API for the load balancer itself, so not the services. It's different from normal application load balancer. Should just check my progress here. Let's go. Set up the internal load balancer. You see, creating the single private VIP virtual IP entrance for your internal service. It allows other internal application to reach your prime number calculator reliably without needing to know which specific backend VM is active or available. In this task, you set up the internal load balancer and connect it to the instance group you have just created. An internal load balancer consists of 3 main parts. It's the forwarding role, which is the actual private IP address that other internal services send requests to. It forwards traffic to your backend service. Okay. And then there's also backend service. Basically, this is define how the load balancer distribute traffic to your VM instances. It also includes the health check and health check. This is a continuous check that monitors the health of your backend VMs. The load balancer only sends traffic to machines that are passing their health checks. Ensuring your service is always available. And then the following diagram shows how instances are load balanced using multiple instances in multiple backend groups in different zones. So there's a client instance, forwarding role, and then the original backend service, which is they will forward or just like the name forwarding role is their internal load balancer IP. And yeah, there's backend 1 and then backend 2. I see. So yeah, let's just create the health check. Cloud, compute, health checks, create HTTP, internal load balancer health request path. What does the divide to means? Slash to means? I don't know either. Okay, in this case check is populated. Okay. Then we will create a backend service. You cloud, compute, backend services. Oh, create prime service. Load balancing scheme. Internal region Europe. West one. Protocol, TCP, health checks. Be health. Oops, another typo. My bad. The service ties the health check to the instance group. Yep. Instance group, prime service. Okay. Add the instance group to the backend service. That's what I said tadi. Run the following command to connect your backend instance group to the prime service backend service. This tells the load balancer which machines it should manage. Okay. You cloud, compute, backend services, add backend, prime service, instance. Oh shit! The fuck happened? Load balancing. Not that one. Instance group, backend, instance group, zone. I think we already did this, no? No, we haven't. Then group zone, Europe, 1B, region, Europe, West 1. Create the forwarding rule. Okay. Oh shit. Back answer. Oh, okay. So there's another typo. I'm sorry. When we don't know what command does, like what do you mean, like add instance group to the backend service? We just gotta pull out the Gemini. What does that means when it says add instance group to the backend? Shouldn't it means add backend to the instance group? Well, Gemini is their own product, so they should know what we're talking about. Yes, Google Cloud platform names. Yeah, we have front end, which is the forwarding role. Not necessarily front end, but yeah, whatever. And then target proxy or URL map. Backend service, instance group. Okay, so instance group is the actual workers, the virtual machines. So backend service, the logical manager. The key to unraveling the phrasing is understanding the difference between a backend service and an instance group. The backend service, the manager teaches specific logical resources in Gadget. To actually complete anything itself. Instead, its job is to manage how traffic is distributed, monitor health checks. Okay, so backend service is the one who distribute the traffic and then monitor the health checks and also manage caching. And the instance group, which is the workers, this is the actual cluster of compute engine virtual machines that run. Add the instance group to the backend service. Okay. The load balancer is the host, the backend service is the teacher. Okay. And if you don't know what they're talking about, just use the image and I see. Could you maybe create a diagram so that I could? Oh, maybe you could just use this diagram, right? So this is the backend service. This is the instance group. So what means is backend. There's only backend, the three backend that we just created tadi in the VM instances. So that means we gotta create the instance group. That's why it praises add the instance group to the backend service. Okay. We next create the forwarding rule. In rules, create prime LB, load balancing, scheme internal, port 80. Oh shit. Yep. Network default. Okay, we just need to add that. I forgot something. I use this bagi-bagi as a service to. Yeah, let's add it quickly. Browser alert. Okay, so whenever someone make a donation, it will appear there. I forgot to set it up. Okay, it's done. We should check the progress, which is should be done too. Hell yeah. This step is crucial to confirm that your internal application load balancer is correctly directing traffic to the backend services. It proves that other internal application cannot reliably reach your service through a single static stable IP address. Okay. Okay, since the load balancer is an internal thing, so we could only test it from inside our VPC or virtual private. What's the C? Okay, virtual private cloud. Okay, we gotta create the new. Okay, it takes some times. Then we just need to SSH into it. Whoops. Yes, discontinue. No passphrase needed. Okay, we gotta need the we gotta know the IP, right? So this is the IP. Just gotta crawl it. Oh yeah, this is the. Okay, nothing happens. What? Okay, I don't know why nothing happens. We already SSH. Or have we? Or have we not? Okay, connection refused. Hmm. Test instance was a success, right? Where is it? Let's try it. Let's try it again. Okay, we're in. What the hell? Let's try it again. Yep, true. 5 is a prime. Is 4 a prime? Nope. False. Exit. And then delete it. No, task 5 there is create a public facing web server. Hmm. We gotta. Oh, what the hell is happening? I'm gonna open the editor and then select the file, which is front end. Just copy this. You could ask it, but I do not want to ask it because yeah, basically it's a Python. I think it's a Python. Yes, it is. To get the URL and serve some basic HTML, something like that. Oh, don't wanna exit. Then we create a front end instance. Oh, we're using the file and the script. Open the file to for front end. Okay. Okay, share instances. Should have front end here. Okay, we have a front end here. We have external IP. Let's try it out. Yep. we get this side, which is a matrix that says this is prime, this is not prime, whatever, and we're essentially done. Let's go! It took us like how many minutes it is? I do not know actually. Let's see it ourselves. Oops. It took us okay 30 minutes. Not bad, not bad. Okay, it's done. Let's end it first. And the lab is I'll submit 5 star because it is a 5 star meetings. So I've done the load balance, network load balancer, application load balancer, and international internal application load balancer. That's quite a lot. But before that, I want to explain uh, how network load balancer really works. So first thing first, we need to know the OSI layers. Don't really need to know, but I think it's a good thing to know. So basically, the difference between network, yes, NLB, network load balancer, and application load balancer, and application and network is only in the layers. So applications, yeah, basically on the application itself, application. Yeah. So for example, whenever you wanna, let's say, route something to, oh, where is it? How do I text something like this? To this will route you to the bucket service. Meanwhile, uh, and this will route you to the picture surface. You see the idea there? An application load balancer distribute your traffic based on your URL params. So there's an URL map. So the basic components of application load balancer is, I would say it's the URL maps, and then the backend, and then the alt text, obviously. Yeah. Basically, everything is the same. This is so basically the user can access domain bucket and it will redirect you to bucket surface, domain picture, and to picture surface. That's application. And if internal application, just think of this, but for internally. So instead of having one public IP, which they will redirect you the surface to the surface, an internal, it's gonna be only internally. So the user couldn't directly access to this. Nope, they cannot. They just can access to this, the IP balancer, and that not IP balancer. What does it call tadi? The backend service lah. Not the backend service. The forwarding roles. The forwarding roles. Nah, the forwarding rolesnya itu nanti bakal distribute traffics based on what the user needs. And network ini kan HTTPS ya, or HTTP ya pokoknya itu for application, because kesini kita langsung ke URL nya. For networks, it's a raw TCP, that's why it's fast, and basically it's the one. This is the one. This is because also call this NLB. Not really. Let's see this F1 one public IP, and there's 3 instances, and this IP will distribute everything based on their resources. So let's say it's 1, 2, 3, So they will distribute it to, if you curl, misalnya curl, and then loop the IP, it will distribute the, it will show the one, two, three, or two, or three, or one, based on the these instances or resources or usage gitu. Okay, that's a little bit explanation of what is really load balancer is all about. Basically, it's just distributing things, distributing traffics. Yeah, I don't really know itself because I'm just a beginner and noobs, as the title said. But yeah, let's learn with me. Okay, one last thing before I go off. Maybe I'll try this. I complete it in 30 minutes. That's a lot. Yeah, why not? Why not trust this? Compute engine. Oh, it's not that long. It's very short. Okay. Let's try this. Like usual, I'll just copy this because we already have it open. And I will hit this to uh, uh, because we need visibility. We need what? We need visibility. There you go. I understand. You are a junior cloud engineer working as part of a team of cloud engineers that are assigned to provide network functionality to compute engine virtual machine (VMs) instances on a Google Virtual Private Cloud Network. Because you cannot create VM instances, containers, or app engine application without a VPC network, each Google Cloud project has a default network configured to get you started. To support load balancing for the network traffic, you need to know the difference between a network load balancer and an HTTP load balancer, and how to configure both for your application running on the compute engine VMs. I just explains that to you basically. Network is the one hitting the external public IP. It doesn't really care about the services, so it's just distribute the traffic to the different instances based on their usage or their resources. And HTTP load is where it's also called application load balancer or internal application load balancer. You're expected to have the skills to know. Oh, it's a lab, right? Okay. Oh, never mind. We gotta do this ourselves. Okay. For this task, you need to create 3 compute engine instances using the configure. Install Apache on them, and then add firewall rule. Okay, VM1, VM2 region, V2. Okay, use the following script. Okay. Network LB. Okay, so basically it's a combination of the befores of the. Yeah, we could just take a peek to see how it really looks like. Where is it? Where is it? So set up network load balancer, set up application load balancer. I think it's all we need. So we don't need this. Let's just go here. I think. What the hell? Let's see. We need the template. There you go. This is the template that we need. Okay. Let's try. Let's try it out. Close this. Open this. We have Google Gemini here to assist us. So that's that. See, when you learn something, it is more optimally that you use an example working example rather than just doing problem solving, because there's a paper on that, I suggest, and there's a video of that based on the person who got fired from Atlassian. So you gotta really watch that if you want to know what I'm talking about. So let's create multiple web server instances. Yep. Mm-hmm. Mm. Okay. So beforehand, we gotta create it one by one like this. But I don't think we gotta do that. But okay. One thing is you can ask. Do you know anything about GSP? Coba let's say. Do you know? And we gotta ask them. For the first task, we need to create multiple web instances, right? Can I use? Okay, in those instance templates for this. Create each VMs manually. There we go. Okay, I shouldn't create them individually. I could use this though. Let's just use this. Oops. Okay, my wife is calling. Let's stop this for now. See you.